What's up, everybody? This is Ryan here, and you're watching episode 23. Oh, my voice feels deep today of my live stream Q&A. Anyways, episode 23. I don't have a whole lot planned for today's episode. I thought I would spend a little bit of time rambling about why I like the launch coroutine builder and why I enjoy launch coroutines in general. But other than that, I plan to basically just take viewer questions today. One thing is I'm pretty sure Gen 2 had a question that I had missed last weekend, so I'll make sure I don't miss it this weekend or today. But yeah, that's pretty much it. Unfortunately, I probably say this just about every episode lately, but I do have to apologize. I'm pretty tired today. It was a long week. But I will press on and do my best anyways. What's up, Piyush? One of the tricks that I use when I'm tired but I need my brain to work well is to combine fasting. So the last time I ate was like 2 o'clock yesterday, and that was just like a small meal. And then a bit of coffee helps to get the ketones going. So that's kind of one of my little tricks. Anyways, we already have a question rolling in here. So let me just talk briefly about what I promised to ramble about at the start of the show, just to keep our advanced people a little more happy, our sort of more senior developers. So if you're a junior developer or you don't have any experience with the Kotlin programming language, this little bit of rambling is probably not going to make a whole lot of sense to you, but that's totally okay. Let me just get set up here with a high-tech WordPad window. I like WordPad. It's just a nice, straightforward, simple IDE. What's up, Nikhil? How are you doing? Okay, so what I wanted to talk about today, and I'll try to keep it really brief, is I'm sure like pretty much everyone listening to this, you've all heard of like reactive frameworks. So in Java, obviously we had RX Java. You've heard of all the different RX things. There's like RX Swift. I'm sure there's RX JS, I think it's called. There's all these different options. And now in Kotlin, we have Kotlin Flow, which is essentially modeled, I would say, after reactive frameworks in general. And just to give people a bit of history, RX Java really started to take off in Android development sometime around maybe, I would say 2017 is when, that's certainly when I first learned RX Java. And RX Java was very fascinating because RX Java solved a number of problems at the same time. Like, let's just give a really quick overview of what RX Java is, just for educational purposes. RxJava basically does three main things. It is it's an implementation of the observer pattern. So if anyone has any questions about what that is, I can show you you can actually implement the observer pattern using 2 files, and you can have a basic observer pattern set up that you can use. But it's a lot more than that. It's also a concurrency tool, so you can use it for threading. And then the other thing that it did is it gave you this sort of chained method call syntax. So probably it's literally been years since I wrote RX Java code, because I transitioned to coroutines quite early. But in RX Java, you would have like, I don't know, flowable dot, what's an example here? I can't even remember, but dot flow, and then you would have these big long chain method calls with like observe on main thread, whatever. This is just pseudocode. Subscribe. Is that the same as observe on? There was some other method you could do, like do on cancel. You had all these different things, you know, do this, do that, and then inside these function calls you would have lambda expressions. So you would have like a, I don't know, variable arrow thingy, variable dot blah, just this kind of thing. And the thing about this is that if you're fluent in RxJava or Flow for that matter, and you really like reading and writing code that way, you can do that and it works quite well. But the point I wanted to get at here, what's up Suraj and Pemba? The point I wanted to get at here is that this is, to me, a very unnatural way for me to write code. And the other thing is that, like, don't get me wrong, I'm used to lambdas and I like lambda expressions. But if you're not used to reading lambda expressions, the first thing you're going to do is you're going to look at something like this and you're going to say, where does this variable come from? Now, if you are aware of it, then if you know how lambdas work, you'll know that the type of this variable must come from this particular function here, or the function it's attached to, or whatever. I'm tired, so expect small mistakes like that. But it's just not a supernatural way to code. And so the one thing I wanted to ramble about today, and this is not me advising you to avoid Kotlin Flow or any reactive framework, but I just want to show you that there's a different way you can do this. And to me, I find it really easy. Here's a general thing. I'm going to have to paraphrase something that Roman Elizarov said, and this is a paraphrase, not a quote, because I'm terrible at quotes. But it's something to the effect of, it is never easy to read someone else's concurrent code without any explanation. This is probably very far from what he actually said, but I just remember Roman Elizarov, who is the, what do you call that, the lead language director for Kotlin. Like, he decides what happens in Kotlin next. And this is a general point. Reading other people's concurrent code is really difficult because concurrency in general is probably the most difficult topic, certainly in programming. And then there's so many different ways to do it. So I'm going to wrap this up really quickly because we have a couple of questions already, and I will get to that. But here's the thing about this. This is what I wanted to talk about today. The launch coroutine allows you to write concurrent code in direct style. So let's basically look at two different approaches. There's direct style, which is basically, I'll just show you what it is, synchronous. And then there's CPS, which is asynchronous. So direct style means basically the way you have been writing code since you started. So in direct style, you start from line 1 and then you go to line 2, and then if there's a function call, you might jump to line 30. But the point in direct style is it goes top to bottom, but it also has ways to jump to different lines in the file. Whereas in asynchronous, it does something differently. This means, so CPS, continuation passing style, just means callbacks. That's all that means, just callbacks. So this would be, for example, having our, in our Rx chain method thingies, we would have on, what is it, on success, I think, ... You would have a callback. When the thing completes successfully, then you do this. This is continuation passing style. And this is the way most of us are used to writing Gentoo. Is this similar to promises in JS? Yes. So a promise would be a continuation passing style, I'm pretty sure. I'd have to look at it just to be sure. But if it has a callback, yes. Now the problem with callbacks, there's a number of things. You can do it in this sort of big chained method call style, and that can work. Some people like to read it. Some people have an easier time reading this than others, and that's fair. But one of the things that can happen in continuation passing style, where we've got these callbacks, is you can get these staircases going on. And if you're a JavaScript developer, you've probably seen this kind of thing. Sorry, Notepad is not behaving very well, but this is the kind of thing we're talking about. And that's where one of the big limitations of continuation passing style or CPS. Oops. Sorry, I'm trying to make this look somewhat descriptive of what I'm trying to tell. So this is, just to summarize, this is CPS, continuation passing style. And in direct style, really just think of the way you've always been writing code before you saw callbacks or Lambda expressions. Okay, so let me move on to the code demo. Let's talk briefly about the launch coroutine. So what you want to do with coroutines is, where is my logic class? Someone asked about writing logic. What you want to do if you want to use, say, the launch approach, which uses direct style instead of callbacks, but you're still writing, this is the key here. Let me actually, yeah, it allows, the launch coroutine allows you to write concurrent code, which does not block the thread it's on in direct style. And this is a really important point that I think a lot of people miss. They see the really simple examples of the launch coroutine and they think this must be the simplest thing ever, and obviously you need to use flow if you want to do anything complicated. And instead what we can do is you can set up a coroutine scope. I'm going to breeze through this quickly because otherwise I could talk for a half hour. You set up a coroutine scope, and just so people are aware, this is what a coroutine scope is. A coroutine scope is a life cycle. It's saying when the class that is the container for the scope dies, shut down all the coroutines. So that's what a coroutine scope is in very simple terms. It's a life cycle. So we set up a life cycle, in this case in my presentation logic class. And we do something. So let's say we want to get the data. So what we do is we have just a plain old function, and then we say equals launch. And then what we do is we jump into, I'm just going to ignore the chat so I can get through this quickly, but I'll address your comments in a second. We say equals launch, and then all of a sudden we can do something really, really cool. So now, as soon as we say equals launch with the brackets, we're now in non-blocking, so thread, it's not blocking the thread, concurrent direct style. This is really cool. This means that we can write asynchronous code, so code that will await a result, similar to what we see in continuation passing style, except we don't need to have this situation here. We might have similar situations, and you'll see that in a moment. But you can write things synchronously as far as it seems, but it's actually working concurrently. So in other words, we ask this use case here, or we call this function data result, we get some result, and then we just throw it into a when matcher or an if-else statement, and we don't need any kind of callbacks here. We don't need to use continuations. Under the hood, that's what's happening. But using the launch coroutine, we can write code which you don't have to write, you don't have to do this kind of thing here. You can if you want to. So I realize a lot of people are going to be jumping in the middle of this lesson and thinking I'm crapping on RxJava. That's not the point. I'm just showing you a different way. So let's actually see what happens. So let me just go to get private list data. So what happens here is, depending on whether the user is logged in or not, we will send them to the registered or anonymous note source. The anonymous one just works like a note-taking app. It's just a local room database. The registered one has Firebase alongside a local room database and a local cache database. So we're going to jump into that. And let's see here. Registered note source. All right. So this is a use case. Now, what we're doing here is the functions we're calling from the launch coroutine are wrapped in a suspend, or have the suspend keyword. What does this do? In a sense, exactly the same thing as the launch coroutine builder. They behave the same way, is a better way of putting that. They don't do exactly the same thing. What I mean by that is, again, we can write asynchronous code in direct style. So instead of saying like something like locator dot I don't even know how to write this in Kotlin basically, but something like a lambda result this, and then we've got an on success and on error type thing. You can just return some result wrapper here, which is what I do, a result wrapper, and then you check what the value is. Now, obviously, this is quite similar to continuations, same idea. We're representing two different event streams with in this case, a single object, which is a result wrapper. But this is actually a bit of a complicated use case, because what we're doing here is first we're saying, check the local cache for anything the user has done offline. And if there's things in there, obviously we need to synchronize the local stuff with the remote stuff. So we jump down into this thing, and then we jump into a repository. And the point here is that we can make ample usage of helper functions to clean up this synchronous code, which you should be doing anyways, and to avoid these kinds of situations where you've got these staircases. So things get a little more complicated from here. We can jump into the, let's see, which one is it? We can jump into here, which is where things go next. So this is a repository which depends on two more repositories, because I made extensive usage of interfaces in this particular application, because I knew things were going to change a lot, which is why I did that. So anyways, basically, what happens here is, again, we're in a new place. We want to ask the transaction repository, the local cache, for any changes to the note database that the user has made since they have not had an internet connection. And then we attempt to synchronize the cache to the remote, which might mean either deleting something or adding something, update results and delete results. And then we basically just try and do that, and if there's any error, we throw a generic error. I think I'm going to shut up at this point. So, but let's just try and summarize what I'm trying to tell you here. Don't underestimate the power of using the launch coroutine, which allows you to write concurrent code, so you're still not going to be blocking. The application's not going to hang unless you do something really wrong. But you can write it in direct style, which means you don't have to do the big chained method calls unless you want to. You can still do like your map functions and stuff, but those are just Kotlin standard library. You don't need Flow for that. So you can even do some of that within your code here. And it's pretty easy to not deal with the situation where you've got the callback staircase to hell and all that kind of thing. It's not that different from using CPS, but I just personally find it more familiar, because even though all of this stuff is asynchronous, so it'll await, this is similar to like a promise, it'll await the result before it resumes execution. So it awaits the result of remote update note. Even though that's the case, it's still written in this kind of direct style, and that's something I really appreciate. So I'm going to shut up at this point because we've got a fair number of questions, but I just wanted to ramble about the launch coroutine, and the whole purpose of this little lesson was just to say that I appreciate the simplicity. Sometimes I really appreciate simplicity in writing fairly large and complicated applications, because yes, you can become that person who is an absolute wizard with Flow or RxJava stuff, and I do respect people like that. But the problem is, unless your whole team is on board with that and they're familiar with that, it's really hard to read. So, anyways, not saying this stuff is a whole lot easier, but I do think it is easier to read, at least for me. All right, let's get to some questions because there's no shortage of them. Let me just see. I'll just take the questions that were to do with my coroutine rambling first, and then we'll get to the other ones. Let's see. I think there was one. Tamita says, Timati, sorry. A little bit dyslexic today, apparently. I'll call you Tima. Says, but we can run a suspend function with blocking thread if we use run blocking. Yeah, well, don't do that. I'm not telling you to do that. Like, don't use run blocking unless you have a very specific reason to. That would be a terrible idea. That's a valid point. Okay. All right, so that's basically, I think that's everything. Let's start from the top now. I know Jantu had a question, so as soon as you, I'll be looking out for it. Okay. So Gaming with Guntavia says, Ryan, can you give me some tips in logic building as I am unable to do so? Now the problem. So the thing about this question, I'm happy to do that, but I don't know exactly, very specifically, what you mean by logic building. So could you elaborate a little bit on that? Like, could you give me an example problem that you want to solve? Because I could assume you're talking about writing classes which are loaded with control logic, which is what I would call it. While hopefully you're responding, here's an interesting thing. 2 years ago, I went through code, pretty much every kind of GUI code I could think, and I classified them into different categories. So we had logic, which had 2 elements in it. We had control logic, which is logic to do with the flow. So you can think of like if else type stuff. Then we had computation logic, which is essentially mathematics of quantities. And then there was actually a subset of control logic, which I call build logic. So this would be like dependency injection, just not literally, but that's an aspect of this. The code required to build things and satisfy dependencies. And you'll notice in like every application I've written for probably the past 2 years, each primary feature in the user interface will have a package called build logic, and within it you will find build logic, the logic required to build and wire things together. So those are the main delineations of logic that in code that I'm aware of, and this will usually be represented by a presenter, a controller, that kind of thing for control logic at least, not necessarily the computation logic. So, did you respond? Not yet. Come on, Gaming. This is one of these questions I either have to give you everything or nothing, and at the moment I'm trying to give you everything. Okay, here we go. Thank you. Oh, I know what you mean. So I would call that algorithmic thinking. That's a cool question. Okay, cool. Um, I can give you some guidance on that. So, um, okay, so there's a couple different things. There's a couple different elements. So we need a process to I'll say incrementally design. Uh, so these algorithms. So I'm going to use the term algorithm because um, that's essentially what computation logic is. In a sense, also everything is an algorithm in a programming language. Everything is a logical instruction. But I'm going to use this term algorithms because then people can connect it with the field of software engineering. But when I say algorithms, I'm really just talking about functions to do like the thing you said. So let me actually just properly address this question. So um, I'm going to call you gaming. And let me paste in the question. And thank you for getting back to me. Sometimes people will ask a question, then they'll just leave, and that's kind of annoying. So I appreciate that you responded. All right. Ryan, can you give me some tips in logic building as I am unable to do so? And then ... By logic building, I mean that when I have a sum like get the angle of rotation for the player in games and all that for basically for games. So we are pretty much talking about computation logic. Let me show you my process. So the first thing is we need a process to let's say systematically design these algorithms. We need a process to test the algorithms, so to test the logic. You know what, screw it. I apologize for changing my mind, but let's just say logic instead. We need a process to test the logic, and those are really the two things you need. So let's start here. Let me suggest what I like to do. So there is a process I use for designing lesson plans. I've published several courses and I've taught software engineers live. There's a process I use for designing educational content, and it's the same process I use for designing a new program, and it's the same process I use for designing a function. It's the same process. I call it top-down analysis, and this is the process I use to solve complicated algorithms. Now, just so you know that I know a little bit about what I'm talking about, let's look at graph Sudoku. In this application, I have a folder called Computation Logic. As you can see, I'm consistent with what I teach. And in here, you will find lots of algorithms. People are probably going to laugh because they're just like, Ryan, you just crapped on chained method calls. Well, not really. I crapped on chained method calls plus lambdas, but this is, yeah. So this is a Sudoku game, and in order to actually generate a new Sudoku puzzle dynamically, it turns out you need, and to do it quickly, and then to make the game playable, you need to do a lot of steps. First, you need to build the data structure which represents the Sudoku puzzle. Then I wrote this seed colors algorithm. So this one attempts to just make it so that I can randomly assign a certain number of values to make the next step easier. In the next step, I try and solve the entire puzzle, which can take a while. And then in the final step, I unsolve a certain number of clues to then make that Sudoku puzzle solvable. So how did I get there? What did I actually do? And this is really what I recommend for you. So the process to design these things, in my opinion, starts, number one, with plain language descriptions. And this can take two forms. we could do problem statements, or we could do what I call like an instruction list, which is essentially the same thing. Usually I'll do both. So maybe I can find an example here. Let's see. Probably, actually, Space Notes might have a good example. Sorry, there's a lot of classes in here, so sometimes it takes me a minute to find a good example. Okay, so this is a great example. This is literally what I do to design algorithms. First, I will write a sentence which describes what I need to do. So in this case, this would be the sentence you wrote here. You write out the thing in plain language. Get the rotation, angle rotation for the players in the game. You write that out. So we start with the most general description of the problem. That's step number 1. Then we write like an instruction list. So in here what we're doing is we're itemizing, we're writing a list of steps. A and B are different potential paths that the execution can take, so different event streams. So I'll mark, every event stream will be given a letter, and then I'll get to that in a minute, I'll write a test for every event stream. But to simplify a bit, I write the plain language general description, and then I try to write an itemized list of steps. And the point is, I do all of this before I write the code. In the case of writing pure algorithms, which do not have tight coupling to operating systems or any weird code that I have to mock, then the next thing I do is I will write a test, if possible. I don't do a ton of game development, so it might be difficult for you to write tests, although most likely if your code is difficult to test, you're not doing a great job with software architecture. Because almost the entire point of software architecture, half the point is to make your code easily testable. But yeah, I'll write a test. So to go back to Graph Sudoku here, the very first thing I needed to do when I was writing this big giant algorithm, this giant logic thing, is I needed to build the basic data structure, which happened to be a graph data structure. And a graph has these things called edges. Edges are essentially the lines between different points in a network, and a graph is a network. That's a much better name than graph, because graph makes you think of like a bar chart or something. So in order to do that, I wrote a test. So I'm like, okay, I know the first thing I need to do is I need to virtually represent a Sudoku puzzle in this particular data structure. So I wrote a test. Verify that after this code I wrote here, build edges, executes, verify that there are 8 edges in a 4x4 Sudoku puzzle, or 21 in a 9x9. You get the idea. Is that correct? 20 edges? Something seems wrong about this, but anyways, don't worry about it. For some reason that's throwing my head for a loop, because I feel like that should be higher. Anyways, I'm getting bogged down. So the point I'm getting at here is write a test if possible, and then finally we get to writing the implementation. Okay, so this is like verbally the approach I use. Now let's get into some special cases. Let's talk about a situation where I try and write an itemized list of steps, and this is the key. Why do I write that itemized list of steps? I'm basically programming pseudocode doing that. The reason why I do that is to tell me whether I understand the problem or not. Because if I can't write an itemized list of steps without any code involved, how am I going to be able to write the code which solves that problem? Because I'm going to be worrying about writing the code correctly and solving the problem, which are two distinct things. So here's kind of the last thing. Here's some special tactics. As Waitura from Ukraine, old StarCraft player, says, special tactics. Sorry, I should not do that. Special tactics. So you mentioned that you have trouble thinking this way. Here's my suggestion to you, my friend. Explore different ways of working with problems based on how your brain works. So, let me explain something. I had a really difficult problem in this application. I had to do something which was technically difficult. I had to figure out how to rank, let's go to, what is it, unsolved Sudoku. I had to figure out how to mathematically describe the difficulty of a given Sudoku puzzle. Now, I am not really a math guy. I'm pretty bad at arithmetic compared to other things that I'm good at. I can do math in visual land, but I literally have to imagine a whiteboard with numbers flying around. So math is not supernatural for me. The way I actually had to figure out how to represent different difficulties is not mathematically at all. I had to purely logically say to myself, okay, an easy puzzle must use a very simple way of solving. A medium puzzle must use a more difficult way of solving. And then a hard puzzle might not be solvable purely logically. You might have to use some even more complicated things. So in order to actually establish what I wrote as these different solving strategies, here I have solving strategies, basic, advanced, and unsolvable. I had to mentally imagine the Sudoku grid, and I had to imagine what I do as a human being in order to do basic and advanced solving strategies. What does this have to do with the question? What I'm trying to say here is that if you have to draw pictures, use visual imagination, what's another way? If you happen to be really into algebra, represent the problem mathematically, that wouldn't help me at all. But the point I'm trying to get at here is you need to explore the different ways in which your particular brain will be more suited to solving these algorithms, these logical functions. But the most important thing is this computation logic cries out for testing. So if you've never done any testing before, you really need to do that. And testing is not difficult if you architect your applications well. Because in Graph Sudoku here, all of these algorithms are written in plain standard library. There's nothing to do with Android here, even though this is an Android app. It's just Kotlin and Java stuff, and some stuff from the domain layer, but that's also Kotlin and Java. The benefit of doing that is that your code becomes really, really easy to test. You don't even technically need JUnit. I'm not sure if you're writing Android code. I'm assuming you're actually writing in C# or something like that, maybe C++, because you mentioned game development. But explore some options for basic testing, and that'll really help as well. And what tends to happen for me is over time, by writing a problem statement, then the instruction set, and then formulating a test, and then implementing the code, at every step I'm thinking and designing in my head what the actual code will look like. But I'm doing it in a very concrete way, a step-by-step way, and that's what works for me. Hopefully that answer was useful. Okay. Next question. All right. Question from Let's see here. Tima asks, hey Ryan, thank you for your content. I'm Russian student, Privyet, who started to learn Android since February. I have a question. Is MVP still a good pattern that we can use? When was the last time I rambled about this at length? Tima, or whatever your name is, I'm going to point you to a video. I will answer your question, but I'm going to point you to a video, which is basically the video that I advise anyone who wants to learn software architecture from me, start with this video, because it's it helps. The unfortunate truth about, if I can find the friggin' thing, where is it? The unfortunate truth about, sorry, I'm trying to do two things at once here. Free, show me the free course preview. Here we go. Okay, so I'm going to write a comment in here. So the video is called Software Architecture Explained Simply, MVP, MVC, all this stuff. All right, and let me just close that out. So here's the thing, Tima. So most people who teach/write about software architecture don't really understand it at a deep level. There are some people who do understand it at a deep level, but most people who write the average article like MVP versus Mvvm, very few of them really... The more I understand about software architecture, and I've been studying this particular topic for a long time, this is a silly question to ask. Like, people always want to know which software architecture is best, MVP versus MVM, or what about MVC? What about MVI? Let's start off with this one. So, here's the thing. There is not a single architecture which works best in every situation. There is two things to consider: project requirements and personal preference, which is essentially a project requirement, but I just like to throw that out there. So to answer your question, so I'm going to seriously watch that video. Seriously watch that video, please, because it will explain the most important stuff you need to know about software architecture. But to answer this question, is MVP still a good pattern? So Mvvm is really not spectacular in any way. It works well in some situations and poorly in others. And everyone's going to be like upset about that. Not everyone. The people who are regular viewers know what I'm like, but let me talk about what makes MVP amazing and why MVP is far superior to Mvvm. Here's what it is, and this is the reason. MVP is really not spectacular in any way. It works well in some situations and poorly in others. Okay, so hopefully you're picking up what I'm putting down here. Now, probably most people, you mentioned this, the Android team suggests Mvvm. Let me tell you something you might not have known. In a podcast, the Android developers, I believe it was Yeet Boyar and perhaps Roman Guy, I think it was Yeet Boyar, admitted that when they looked into MVVM, they saw that people don't do it the same way. So the irony is that everyone's talking about MVVM and is it the best architecture, and most people don't even do it the same way. It's depressing. I'm going to show you one final thing, and if you have more questions on this topic, I'm happy to go into that. But what am I suggesting you do? Well, you can do MVVM, you can do MVP, you can do what I do. Let me pull up a picture, that'll help. Just give me one moment here. Ryan.exe is loading a photo or an image. Here's my latest approach to software architecture. Oops, there we go. Model view, whatever. It's got a presenter and a view model. Why? Because I followed the principles of software architecture. I like the fact that the view can observe the data and update automatically, and that the view model can't talk to the view. I still like having a presenter, because what I don't like having is one giant view model that behaves both as a view model and a presenter, which is what a lot of people do when they do MVVM. They create a giant ugly view model which is full of logic and it stores data. And if it's full of logic, it should not be called a view model, in my opinion. That's just not a very descriptive name. So, anyways, please watch that video and understand that to say that MVP is still a good pattern is the same level of saying that MVVM is still a good pattern. In some situations, it'll work well. In some situations, MVP will work well. Let me just give you one final thought here. If you choose to force yourself into 3 layers, which I don't really suggest, but I understand that's what most people do, MVP is great for features which have complex presentation logic, but bad in features which store lots of session state. When I say session state, I'm talking about the stuff that you would store in a view model. Conversely, MVVM is great for features which have lots of session state, but bad in features which have lots of complex presentation logic. Because the reason why is that by choosing to observe the view model instead of having an arrow pointing from the view model into the view, here's what you lose. You lose fine-grained control over the view. So what I'm getting at here is that in both these patterns, the feature of the pattern is in a different situation a flaw, which is why in many cases you'll find me doing both. I'll do a presenter and a view model. And that way I get to keep the best of both approaches. But it's admittedly a little more complicated. So hopefully that's useful. Let's go to, holy crap, I have so many more. Okay, I'm going to try and go through these questions quickly again because I'm just blown away at how many questions I have here. Gaming asks, by the way, can you tell me a lightweight Android IDE as I have a potato laptop? I'm really sorry, gaming, but there isn't really an IDE I recommend outside of Android Studio. Eclipse ADT, if it even still exists, sucks. Eclipse itself is fine, but Eclipse for Android, that's what I started with in 2014, and it's just terrible. You could, I don't know if it's any more lightweight, but maybe you could use IntelliJ Community Edition with Android support. But you're pretty much confined to IntelliJ stuff unless you are like a pretty good low-level programmer and you can really work your way around a CLI. There isn't really a good lightweight editor or IDE for Android, to be honest. Oh, here's the thing you could do, though. Here's the thing you could do. I'll just rate the question here. Gaming asks, by the way, here's the thing you can do. JetBrains Projector. I haven't used it yet, but all my developer friends, not all of them, but most of them are talking about this. JetBrains Projector, remote, whatever. I think it's a VM. I don't actually know. I'm assuming it's a VM for doing Android/Kotlin stuff. Just Google that and see if it works for your situation. Okay. All right. Здравствуй, Григорий. Как дела? We got a question from Bully Programming. Whoops. Do you program every day? How do you take breaks to avoid burnout? I answered a lot of these questions in a recent live stream. There's actually a video I would like to suggest to you. I'll give you a short answer here. We went over a lot of this stuff in a recent live stream. And if you really want to know my approaches, then this will help you. So I'll just, again, paste a link, and Bully, you might want to watch that. I realize it's 25 minutes long, but, you know, not everything can be taught in 3 minutes. Do you program every day? So I work every day. Most days I will do programming, but the thing about this is that I am a content creator and a programmer, which is really difficult to balance. Really, one of the reasons why my channel sucks so much is that I do something that most other people don't do, which is that I try to write a lot of code and learn advanced topics and low-level topics, and I try to be a content creator. And it's really hard to do two difficult things well, and these are both really difficult things. But the reason why I bring this up is just that, let's just say I was only programming. Man, that would be easy. You guys who like only write programs for a living, you have no idea how much easier that is. If I only did programming full time, I would aim for about 4 to 6 hours of coding a day. Again, unless, you know, this is assuming I have control over my own schedule. I would aim for about 4 to 6 hours of coding a day and 2 to 4 hours of studying. Excuse me. So that's what I would aim. Oh, that was a good voice crack. That's what I would aim for. Now, how do you take breaks to avoid burnouts? So, there's a lot of different factors which lead to burnout. I'm trying to think of how to really address this, maybe in a new way that's interesting. So go watch that video, and in that video I talk about the difference between being distracted and tired. And the biggest thing you need to do, in my opinion, to avoid burnout is when distracted, fix your mind. When tired, rest. So there's really, this is really difficult to explain. It's easy for me to observe it because I've spent 7 years watching my own mind, almost 8 years. But there's two different things that kind of lead to a feeling of burning out. One of them is that you're distracted and disinterested in what you're doing. And the appropriate response to that is not to take a rest, but to do something to get your mind right. And then if you're actually tired, like you're sleep deprived or physically tired, you need to take frequent rests. So I'm not going to get in. Talked about the mental side of this thing a whole bunch. I talked about the mental side of things a whole bunch in that video. So let me focus on the physical fatigue side of things. So this is really the situation. Let's say you're physically tired. So roughly once every 1 to 2 hours, either take a short walk or take a 8 to 12 minute power nap. Why do I say 8 to 12 minutes? Don't do long naps. Lay down for 8 minutes and just relax. And yeah, that, I find that really helpful. Every 1 to 2 hours or so, take a walk or something. Stop doing what you're doing, essentially. Put down everything that you've been carrying for 10 minutes, 15 minutes, 20 minutes, whatever you need to do. One of the most important things here is if you're physically tired, you don't actually want to push yourself really hard. Because if you're physically tired and you keep pushing yourself, then you will get sick. That is the best way to know if you pushed yourself too hard physically, is you'll get sick. And especially with this pandemic going on, you don't really want to compromise your immune system. So that's really the main thing I would focus on. And yeah, I think I'm going to leave that there. Most of what I wanted to say was captured in that video, and a lot of the people who listened to that last live stream are here, so I don't want to bore everyone by rambling for 30 minutes about the same topic. But do watch that video, and hopefully that was useful. Python versus Java. That's a good one. I might get to that question in a bit. Let me see if I missed anything. All right. Bully programming was last. All right, so Aditya asks, Aditya asks, am new to DI, so my question is, can I go with Dagger 2 first? Oops, I didn't do a great job copy pasting there. Then switch to Dagger Hilt or just go with Hilt. To be perfectly honest with you, Aditya, so this is again something I get asked pretty much every live stream, but let's just start here. So before you do either, write a simple app which has handwritten dependency injection. And the reason you mentioned you're new to DI, and the reason why I'm saying this is that this is a really important thing. Dependency injection is so simple that I could explain it to a 6-year-old. Dependency injection, or what you're doing there, is really, really simple. Dagger 2 is not simple at all. And then Hilt is a simplified version of that. I haven't actually worked with Hilt because I've just gotten used to not using a DI container at all, and that works for me. But I have used Dagger 2 a lot. It took me like 4 months to understand what the hell Dagger 2 worked like. I suggest you start by writing something like this. So we have this class here, class active game logic, and it has a bunch of dependencies in the constructor. And if we wanted to do this Dagger 2 style, we would do something like @inject. And then we would write our module and then our component. It's been a while, but you'd write all that kind of stuff. But we can actually write the code that Dagger 2 generates for us by hand really quite easily. You would just write something like this. In this case, the activity here serves as a container for the UI, the view model, and the presentation logic class. And I just write an extension function, build active game logic, which would be like your Dagger component .inject or whatever the hell you use nowadays. That's essentially what I'm writing here. You pass in the dependencies, and then you just build the thing. And the reason why I would suggest you do that, why is this thing, I'll deal with that later. The reason why I would suggest that is this allows you to understand what these tools actually do for you. Now, as far as Dagger 2 hilt or Dagger hilt, I would probably just go with hilt. The honest truth about Dagger 2 is that unless you're building a large and complicated application, the actual benefit you'll get from figuring out how to set up Dagger 2 versus either writing it by hand or just using a simpler option is pretty low. You'll be attractive to employers, but Dagger 2 in a small application is kind of like buying a Tesla Cybertruck to just drive down to... That's a bad example. I really like Tesla Cybertrucks. It's like buying a tank to drive to the grocery store only. It's it looks cool and it's scary and complicated, but it's unnecessary. So probably I would go with hilt, but when I tell you that I haven't used Dagger 2 or hilt, I've never used hilt at all. I've used Dagger 2 a lot, but not for the past 2 years. So the main thing I'm getting at in this answer is understand that there's dependency injection is really simple. These other things are not. And I've made videos on the topic of dependency injection, but YouTube sucks and they never show my videos to anyone. So if you're curious, I explain what these tools do and give a really easy code example in some short videos on my channel, which nobody watches. All right. Harishas, what is your typing speed? I'm trying to improve mine. It's been a while since I did a typing test, so I'm not really too sure. I'm also pretty bad at typing today. Oh, this website looks terrible. All right, let's see what by the way, I just randomly pulled this website up. Okay, here we go. Only bears and great apes walk the same way as we do on our heels. Most same way as... Whoa, this is confusing me. Oh, I can't read the line. Which line is it? What is going on with the... Sorry, this typing test pisses me off because it moves the lines around, so I can't track it. Okay, that is not accurate. I can do better than that if they didn't randomly move the lines around while I'm in the middle of typing. Anyways. So yeah, apparently 50, I can write 50 words per minute. I'm sure I could do better, but yeah. All right. Yakov asks, any tips to learn to write custom views on Android? Any tips to learn to write custom views on Android? Just dive in and do it. What's the last time I did that? Let me see. Just give me a moment here. I'll have to pull up some code. I think it was some sort of day planner. All right, let me just any tips to learn to write custom views on Android? I have poorly math basics. I have poorly math basics as well, my friend. Okay. So, sorry, it just takes me a minute to find the code. Let's pull that up. And UI. Oh, where was this custom view? I think I had 2 custom views. Daylist item view. Was this it? Sorry, I'm trying to find an example of a compound view that I wrote. I thought it was day view. Here we go. This is the one. Is it? I'm so confused now. Extends view. Is this like an old... That doesn't make any sense. Why is it empty? You know, just while I'm flailing around here, just a pro tip for everyone doing live content. The key to doing good live content is to just be okay with whatever happens, to feel comfortable even though you're trying to find some demo code and you're just completely failing at it. Just be cool with it, and whatever you feel, the audience will feel. Okay, this looks more like what I was trying to get at. The way I did a custom view in this particular application, I wanted to make a color picker view. So the basic process is, let me just find the layout here, color picker view. Color picker sheet. Okay, so what you can do is you can, and this is basically all going to go away with Jetpack Compose, but you'll write a view, a layout to describe the view that you want, and you'll give it the child views that you want. So pick a root to be something like a constraint layout or whatever layout works. Excuse me. And then you'll have whatever widgets you want in this particular custom view. In this case, obviously, there's I'm not sure if I could show you what this thing looks like easily. I guess I could try really quickly. I don't know if I have any screenshots of it. Screenshots. Where the hell would these screenshots be? Of course, I'm not going to find one with a color picker view. That would be far too easy. Oh, I have it in InVision. Sorry, I'm just desperately trying to not open up another instance of Android Studio, otherwise the stream will get super laggy. Just give me a moment here. InVision wants me to sign it. Okay. Sorry, I wanted to show you a visual representation of what I was talking about, but this is the kind of thing I'd need a minute to prepare for. In general, you'll create a layout with all the different widgets. This is a custom bottom sheet which has 9 image buttons, which are colored circles, and so it's a color picker view. And then you'll write a Java class or a Kotlin class, which extends either constraint layout or something like that, some kind of view. You'll have all of the different child widgets in here so that you can get a reference to them. What you can do is in the constructor for the custom view, you'll call the super for the constructor. And then what you can do is you can write like a build function. So what you're going to do within this function is you'll inflate the view. So you'll give it a reference to that layout. And after that, you can bind to those particular views. You can get a hook to each child view. And then from there, it works pretty much the same. You can add your on-click listeners. You can modify the things as you see fit. And this is just an example of a custom view. The way I had to learn it is I had to just dive in and pour over the internet to find some source code examples, which were kind of what I was looking for. So, yeah. The Apache asks, how's the JetBrains thing going? I'd love to hear your progress. So, yeah, I'm happy to share some input here. So for those who don't know, I am low-key, that's a phrase we use here in Canada, low-key trying to get hired by JetBrains. Although there's a pretty low chance that I will get the job. I am preparing for that job application by learning language and compiler development. Now, I did a live stream earlier where I was building my first programming language called Donk, D-O-N-K. But I realized that probably, even though I will build that programming language eventually, I realized that I'll probably need to, the most useful thing for me to do would actually be to write in an interpreter from either Kotlin to C or Kotlin to JavaScript. And that's probably going to take a few months. So I'm thinking of putting the language project on the back burner because I don't think it would be as transferable, although it would be fun. I did get as far as setting up a basic grammar for it. But probably I'm going to move into doing writing an interpreter. So you've probably, let me educate people a little bit. So we have this thing called a language processor, and that comes into 3 categories: a compiler, an interpreter, and then an assembler. So what a compiler does is it basically, the problem is they have a lot of crossover, so don't take this too literally, but in general, in a compiler, take source code from language B and make files of it essentially in language. I don't know why I said B first. Language B. Whereas a interpreter take source from language A and translate it sort of directly into language B. Although understand there's a lot of carryover, and the closer we get to the metal, what I'm actually saying is like, what is the intermediate representation, and do we translate why is my computer seems to be lagging? That's not good. Let me know if the stream is lagging. And holy crap, somebody joined the Patreon, but I can't... Oh, it's my bro Chayton. Thanks, bro. I appreciate that. Because of the font, I couldn't actually see. Okay, sorry, getting sidetracked here. So, really the difference between a compiler and an interpreter, in the simplest way I can think of it, is that the compiler is going to first translate like a whole block of code or a whole source file, and then it gets read by the output in the output source. Whereas an interpreter, it's almost like line by line translating. It doesn't really, again, don't take that too strictly, but that's kind of the idea. And then when we get into just-in-time JIT compilation, then it's like a little confusing. So anyways, that was a random little sidebar. So what I'm going to be working on now, so as Chayton mentions, I was, thanks for stopping by, Guntavia. What I was talking about here is, let me just drink some coffee. So I am probably going to be working on either a Kotlin to C interpreter, or more likely a Kotlin to JavaScript interpreter. But I'm not totally settled, and I'm going to be taking a break from working on my programming language, because at the end of the day, the purpose of this whole endeavor is to become more hireable by JetBrains. Although I am interested in building my own language, but I found out that I could end up wasting a lot of time building a programming language, whereas writing an interpreter or a compiler is more practically useful, because there's no way I'm going to build a Kotlin to Dart, yeah. There's no way I'm going to write a complicated industrial use language. I could learn the process of doing that better by writing an interpreter. At least that's my current estimation. Harish mentioned spend a month doing decoding YouTube algorithm for growth. Yeah, that's a whole month I'm not making content or writing code. The secret to the YouTube algorithm is to have a lot of money ahead of time so you can afford advertising. Or just do what Florian does and just be insanely good at commenting on videos and building a community and releasing good quality content. Okay, sorry. Let's get back on track here. Okay, so that was the JetBrains thing. Custom views. I feel you, the Apache. I wish I could just do educational content 24/7 and just write demo apps, but like you, I have bills to pay. Those bills. The Apache 64 asks, after the stream, what do you do with these notes? Is it publicly available? It's one of those things where if people request it, I will add them. But the truth is that I have so many things going on, and so few people watch my videos, that a lot of these little things, which often take a lot longer than you might think for me to do, like to do timestamps for a video, depending on the length, it can take at least as long as the video. You know, setting up show notes for every show and all these kinds of things. It's something I will eventually have to hire someone for, because I just don't really have a lot of time. But I try to make time when people request them if the show notes are useful. I do typically save them to a file, though, not publicly available unless people request. Okay, the moment Gen 2 has been waiting for, and I'm not even sure if I'll be able to give you a good answer here, but I'll try. I'm sure we have people in the chat who can help out with this. So, Gen 2S, I was asking about HTTP response cache in the previous stream. I want to cache some JSON data in a small app instead of using room.SQLite. I don't know whether it's a good decision. So the first thing is I haven't actually worked with HTTP response cache, so let's look at that a little bit. This app here, Jetpack Notes, does cache data and it uses Room for that. I already forgot the name of the thing you were talking about. HTTP response cache. Let's go. Let's do that. You know, Hurry, some people like short videos, some people like really long videos, and Free Code Camp does amazing with insanely long videos, so it's really not as simple as just making short videos or making long videos. All right, HTTP response cache. Let's have a look at this thing. All right, so what does it actually do? It extends response cache. What I want to know is, how does this thing store stuff? Okay, stub, that's not very useful. Security manager, interesting. Okay, so apparently it's basically just a wrapper for a JSON response, I'm assuming. Looks like it stores stuff in a map. You know, I don't think I have a great answer for you here. Really, so the main thing, without having actually, without having used this approach, JSON can be inefficient, but if it's a small file, like just a JSON response, if it's small, that's probably not an issue. The thing I'm not sure on is, so are you writing this JSON file to storage? Because I've done that kind of thing before, and that works fine. I don't know. Unfortunately, Gen 2, I can't really give you a great answer here because I haven't implemented what you're talking about using the classes you're talking about. And in looking in response cache, it didn't really actually clear much confusion up for me. Obviously, I think the problem here is that it's just giving me these stubs and I need to see the actual thing. I'm assuming, yeah, I don't get why this thing, it must generate something. Oh, it's source code recreated from a class file. That's why it's not showing up at all. That makes more sense. Response. The thing I'm not sure yet is I don't know what cache. I don't know what mechanism it actually uses to store the data. So, and if you would be storing this object in JSON or what the deal is. Installing HTTP response cache. Enable caching of all your applications HTTP. Oh, it runs at startup. This looks cool. I'm sorry, Gentoo. I can't answer your question, but this looks cool, and I do think you should pursue this because, oh wait, this is the Android thing. Now I'm really confused. Okay, well, whatever. How does it store it though? Okay, I'm assuming it uses the file system. Yeah, it looks like it uses the file system. This looks really cool. I can't tell you if it's a good idea. I'm just looking at it briefly, Gentoo. It looks like a nice lightweight tool to do what you want to do, and that gives, as far as I'm concerned, that's a win in my book. Someone mentioned you could use Retrofit to cache the responses, but I sometimes it's cool in a small application to just use like some kind of platform solution. Certainly Retrofit would be easier. Anyways. Bikyan asks, hello, how are you? I'm pretty good. Not bad. I'm keeping the train wreck moving. And then Bekyan asks, for backend system of app, what language is best? So I'm assuming you mean like for server development. There's no single best approach. So I would say the lowest barrier to entry would be a Node.js backend. Node is a JavaScript runtime, and it pretty much you can get a backend going really quickly in Node.js. If you like Kotlin, you could use Ktor. You could use, if you're, I'm sure there's options in, people talk a lot about C#. I can't remember, what was the library that they use in C# or the framework for servers? I can't remember now. Let me see if I can Google it. C# backend. Core, .NET Core? Is that it? I think that's it. .NET Core or something like that. I can't really tell. There's no answer to this. Again, let me just reiterate this. I already said this earlier. There's no such thing as the best language / architecture / anything. Just whatever suits your requirements. So if you have experience writing JavaScript, do Node.js. If you're a C# person, do like NetCore. If you really like Kotlin, these are all going to work. And you can rent a Heroku server or Google Cloud VM to play around with this kind of thing. The problem is this question is so general that I either have to give you everything or nothing, and I can't give you everything. But yeah, I know that's probably not the answer you're looking for. You probably wanted me to say Flutter, or Rust, but no, I don't know. Flutter's whatever. It doesn't matter. I wanted to get somebody asked a really trollish question that I wanted to answer. Python, what was it? Python versus, did I miss it? Where is that question? Python versus Kotlin or Python versus Java? Where the hell did that question go? I'm sure I saw it. Wow, it's like it disappeared. Or I just can't read. Maybe someone was just trolling and they deleted their comment. Okay, whatever. Tech asks a question that I'm not sure I understand. Okay, a fun question. If YouTube algorithms code was public, what would be the changes that you would make? Oh, I understand it. That's actually that is a fun question. I think tech has left, but let's just, let me use this as a moment to complain about how bad I hate YouTube. So here's the thing. When I started in YouTube, it was 2016. And 2016 in that era was a transition. Pretty much prior to 2016 and during 2016, the like to dislike ratio of your video mattered. And that was a big thing. Did people like your video? Another thing that really mattered is uploading every day. Being consistent. Or uploading frequently. Over time, YouTube switched to a model. I don't know what it is right now super well, but it's basically like, what is it, CPM? Clicks per CPI? Clicks per impression. And click-through rate is what it was, CTR. Or click-through rate. And watch time. It might have changed recently, but this is really how the algorithm works. Now, what does this actually mean? So, clicks per impression is basically if YouTube shows you a video either in a search or the sidebar, like suggested videos, every time it shows you one of those videos, a thumbnail, for example, that is an impression, I believe. And then they want to know how often does someone click on that thumbnail or video based relative to how many times we show it to someone. If that percentage is like fairly high, they'll bump up your video. So what does this indirectly incentivize? It incentivizes essentially clickbait. It incentivizes clickbait. It incentivizes people to make titles which are sensational or divisive, whether you agree or disagree. Maybe you want to jump on. Let's say someone makes a video that says that Flutter is terrible. You can probably think of someone who did that. And then they make a topic on a divisive, they make a video on a divisive topic. So people who are in support of Flutter are going to want to jump on and watch that video and comment. And people who hate Flutter, I neither hate it nor do I love it. People who love it are going to want to jump on and agree with that video. So really what this model does is it encourages people to make content which suits the algorithm over educational value and honesty. Now, there are people who can make content which suits the algorithm and it has great educational value and honesty and all that stuff. You can do that. It's just, it's not easy. It helps if you're financially independent and all kinds of things like that. So the other thing they do is watch time, which is kind of more suitable to me because a lot of my content, I'm trying to show you how to build something. And in my opinion, the best way for me to show you how to build something is to build the whole thing on camera. But like Harish mentioned, and I wasn't saying he was wrong, I don't think he was entirely correct. For a lot of beginners, because people make 2-minute videos on Dagger 2, they get this impression that everything, no matter how complicated it is, can be explained in a 4 or 5 minute video. The only way you can kind of get around that is you can be like, here's a 10-hour course on some topic. everything you need to know, which is like the free code camp model. So I guess what I would change to answer the question was, if I could look at the algorithm's code and I could change it, I would make changes which essentially would make less money for YouTube, because over time, and don't get me wrong, I'm not one of those, I'm not a anti-capitalist person. I'm not a communist. Like, I don't agree that everything comes down to money, but in this particular case, I would say that over time, YouTube is more and more just about making money. They're making decisions like every video has advertising, even if you don't enable it. They're moving towards that. Well, that's ridiculous. So really what I would do is I would probably make likes relevant again. Like, do people actually like the content? I would make it so that instead of prioritizing videos from click-through rate, so clickbait, I would once again, this is what they used to do, I would prioritize videos from people you're subscribed to. If someone you're subscribed to plays a video or uploads a video, you should see that right away. I get that there's an alarm bell icon, but most people, myself included, don't click on it. So I would really just make it a little bit more like it used to be, while recognizing that click-through rate is still important, and watch time, I think, is a great metric. How long do people watch your video? So that would probably be the change I make. So that's basically it. I'm not sure what presumably this is just in reference to Dagger, but the Apache says, in my opinion, Dagger is not an Android library. It's purely Java-based. If you try to use Dagger in an Android project, you'll have to use a lot of boilerplate code to make it work. Yeah, I would generally agree. Doesn't Dagger have a library plugin for Android? But in general, I would agree that I don't know if they still use those activity injectors and fragment injectors and all that crap they used to have in Dagger 2. I think they got rid of that, but yeah, it's been a while since I worked with it. Bekyan asks how to learn the back end side of the app related to the client server. You've got to find a good practical tutorial, which I don't have one on back end server development. Consider checking out Free Code Camp. I've made some contributions to them. They have a lot of like full length app tutorials, and probably what I would look for is a something to just build like a note-taking application or something like that with a Node.js backend if you wanted to do Node.js. As far as Ktor or something else, there's not as many tutorials, so Node.js would probably be the easiest entry point. I can't really give you better information than that. So many comments. I guess the one thing I would say, Bekjan, Bekjan, hopefully I'm pronouncing that right. The one thing I would say is do project-based learning. So build a project, build something, and that's really what I would suggest. Don't spend too much time in what they call tutorial hell. This is how I approach every new learning project. Like, I wanted to learn compiler development, so I started building a language. So dive right into something practical and then let the tutorials supplement that, and hopefully you can find either a good tutorial or a good open source project to guide you. That's what I look for. Chayton mentions, to build on that, if you already know Kotlin, you can use either Spring or Ktor, which I've heard before. Those are somewhat popular too. Finally, we have okay. Let's talk about. I want to drop some what's up tracks. So I want to drop some knowledge on this. I think this is almost more of a troll question, but Terrell asks Python versus Java. Ooh, the tension is building. What's Ryan gonna crap on? Let's consider some important differences. So, one big limitation to Python is that it is an interpreted language. At least last time I learned about it. So if I'm wrong, correct me. Python is an interpreted language, whereas in Java, we compile to class files, which get executed by the JVM, the Java runtime environment. Let's just call it the JRE. So this is an interesting thing. So pros and cons. Also another thing for Python. Excuse me. Python, I should just double check. They don't really have types in the same way other languages do. I don't know enough about it to ramble about it though, so I think what it is, Python, it's not a strongly typed language. Oh, never mind. I got that exactly wrong. You know, whatever. I don't know enough Python to ramble about that, so let's just ignore that one. The one thing I do know about it is that you've got the, it's interpreted. You know, overall, there's a couple things. I prefer Python syntax overall, with the exception of white space / indentation based syntax. I find apart from that, Python is quite a beautiful language. But I like brackets, and I'm sure that's just a result of the fact that pretty much every language I've written code in uses brackets, so that's just what's natural to me. So not a big fan of the white space and indentation-based syntax. The thing about it being interpreted is that, let's say I wanted to write a machine learning algorithm in C versus Python. You're inevitably going to have to make a trade-off there. Your Python code, because of the interpretation, is going to take probably something like twice as long to execute as the C code. But if you're writing it in C, it's a much lower programming language. So it's going to be obviously far more difficult, and you're going to probably have to write a lot more code in order to do it. I feel like between Python and Java, it's really, there's two arguments in either way which could convince a person. If performance was a big issue, I would avoid Python. If I didn't have that as a concern, I would avoid Java. I've been writing Java since 2013. I've written significant code in about 4 programming languages, and I've written some code in probably like 8 to 10 programming languages. And having written Java since 2013, we all understand this. Java syntax sucks. It just sucks. It's terrible syntax. It's awful. And having written Kotlin versus Java, you get to see, like, holy crap, the difference is unimaginable. So what I would prefer about Python is that it has the features, the feel of a modern programming language, whereas Java really doesn't. And but the thing that you get with with Java is you get the JVM, and the JVM is one of the best ideas that has ever come out of programming. And that's the main reason why Java has been so dominant and successful for so many years is the JVM. The idea that you can write code, write once, run anywhere, essentially. That is just so important. So that's really what I would say. People are mentioning Kotlin greater than Python, and I completely agree. If the question wasn't Python versus Java, if it was Python versus Java versus Kotlin, that would be an easy choice for me, because Kotlin syntax is beautiful, and you get the benefit of the JVM, and they're working on backend compilers or interpreters to JavaScript and other things. So yeah, definitely Kotlin beats them all out, but that's just some rambling. Hey, what's up, Gabor? Gabor really doesn't like Python. Yep, I can respect that. All right. So, what else have we got? Tech with Guntavia is back running an Android Studio. Oh, that's too bad. I can ramble about this. All right. Who is this? I don't know what your name is, so I'm just I'm not even gonna try. Clearly, that's a screen name. This person asks, "Hi, what do you think about the future of developing applications in native Android versus progressive web application?" This is a fun topic, and we have talked about this before, and I wish I could remember. I think it was Vivek Sharma summarized it so well. But forgive me if it was one of my friends from India. At least I'm quite sure. So really it comes down to this. Reusability, i.e. PWA, is a feature and a flaw. Native is a feature and a flaw. So if you take the cross-platform, let me just actually look up what progressive web app is. That just some buzzword that somebody invented? Yes, it's just a buzzword. Okay. Yeah, okay. I thought so. So let's break this term down for people who aren't sure. So progressive web app, this is like like a cloud. It's like a buzzword. So it's really what it actually means. A PWA delivers applications via the browser, whether it's on a desktop or a mobile device, it doesn't matter. And so this is the key here. A progressive web app, it's browser-based, whereas native, I'm sure we already knew that, isn't. But I wasn't actually familiar with this term, and clearly someone in a marketing board invented it. Because it sounds cool, a progressive web app. All right, so in a PWA, you get, I wish Vivek was here to explain this. I can't paraphrase exactly what he said, but really it comes down to this. By gaining reusability, you lose control over any individual device / OS. But you can obviously reuse code. So I can write just about everything in JavaScript. For example, I could use React Native, which, to be honest, from the people I've asked about who've actually used it, it's not the best. It's yeah. In native, you lose the code reuse, but have complete control over the device. So there's really the question asked about the future of developing things, and there's really two things to look at here. Number one, as internet speeds become faster and more globally accessible, I think I misspelled that, globally accessible, globably, as internet speeds become faster and more globally accessible, it will make more sense to do more things / everything through the browser. So that's true. And then number two, as interoperability between multi-platform languages like JavaScript or Kotlin or whatever, fine, we'll say Dart, etc. As interoperability between multi-platform languages like Kotlin, JavaScript, and all that improves, it will make more sense to use that approach. So really what I'm saying here, random garbled name person, is that over time, I do think that less and less will be native. And when we look at, for example, what Kotlin is doing with Kotlin multi-platform, they're moving towards essentially having a Compose port for Kotlin JS and a Compose port for desktop, and they're working on some cool back-end stuff. Like they're working on their own intermediate representation. This is compiler talk, which all these different languages will compile to and all this kind of stuff. So basically, that's what I'm saying is things are going to move in that direction, but why hasn't it happened yet is really the important thing. Why hasn't it happened? Despite the hype, most of these things don't actually work as well as the language / framework developers would like to think. Because every time I ask someone about how good React Native is on Android, they say it's all right. You can do some things. Every time I ask someone about how is Flutter interoperability with web, they say it's meh. So until one single thing really comes out as being a solid, good multi-platform solution, we're going to see native for quite a little while longer. I don't know, is it 5 years? Is it 10? I have no idea. I don't have a magic crystal ball, but something like that. All right. So, do we have any more questions? That's a good question, Yassine. But yeah, I think Chayton was right. Oh my god, how do I... Just give me a moment here. Sorry, I managed to brick the chat. All right, I wanted to... So I'm not going to go on for too much longer, but I wanted to start a debate. I want to get our awesome viewers, because we have so many great developers here who come out and hang out, and most of the time it's just me rambling. So I wanted to start a debate, and I'm trying to remember what I was going to ask you guys about. Let me think about this for a minute. Let's start with something that is interesting to me. All right, so I want to ask all of my friends here, Gabor, Chaitan, the Apache, everybody who comes here, our senior developers. Here's a thought. Here's what I want to ask you. What is your opinion on third-party library minimalism? Minimalism. I can't. Minimal? Minimal. I swear, friends, that English is first language. I am very good speak English. Okay, what is your opinion on... Yeah, shut up, Trax. You're right. I suck at English. Okay. All right. So what is your opinion on third-party library minimalism? So what does this actually mean? Building apps using only or mostly standard library. So this could be kstdlib and jstdlib, whatever. And well, let's be kind. Let's be kind. Let's throw in Android SDK too. But this, so the thing I wanted to ask people watching here, I'm not going to ask a dumb question. The dumb question would be, which is better? Which is best? And I've already said like 3 times that that's just a stupid question to ask. What I wanted to ask the people, my senior developers watching, and hopefully this is useful for the junior developers or intermediate developers, is this. When do you prefer writing it yourself instead of using a library? When would you write a HTTP URL connection instead of using Retrofit? When would you use the navigation library in Jetpack or Simple Stack, which is Gabor's library, versus just using intents? And the reason why I'm asking this is I'm trying to get people to elucidate where their sort of balance point is. Because on one end, when we use a ton of libraries, it hides problems and behaves like magic. When we don't use many libraries, we have to solve these problems using lower level and more difficult tools. So again, we see that interplay of reusability versus fine-grained control. So this is really just what I wanted to... I'd like to hear some opinions on what is preferable here, because I remember in about 2018, I did a roadmap for Android developers video. And this video, in it, I basically said to people, learn Retrofit, learn Room, learn RxJava. I was all about the libraries and the frameworks. In fact, that's all I knew. And someone came onto that video and commented something to the effect of, I don't remember exactly what it was, but they planted this bug in my head, which was that it's useful to know how to write that stuff yourself. It's useful to know what's going on under the hood. And I thought that was a ridiculous statement at the time because I was still young and naive. And really, I realize in retrospect that you can either be that person who writes everything themselves, or you can be that person who uses libraries all the time, or you can be something in between. And I realized that I was using libraries too much. But the thing about this is that whether you should use libraries or write your own thing, it depends on your personal requirements. It depends on what your job requires you. It depends on your personal goals. So that's why I wanted to bring this discussion point in and try and get some feedback. So first we have from the Apache. When I already know how to build it from scratch, or when I know how it works under the hood, and when it's pretty good and contains no major bugs. So I'm assuming the Apache is talking about using a library. And I think that's a very reasonable statement. If I know how it works, if there's no magic in the library, but it saves you writing a bunch of boilerplate code, and it's not very buggy, because that's one of the problems with libraries. One of the problems with libraries is that you lose control over it. It's not your code. It's the library developer's code. And you're at their whim for whether it works or the API changes. So very good point there of the Apache. My bro Chaitin says, depends. If whole industry take it as a standard, like Retrofit, then I would take it as a third party. I would choose the third party. Otherwise, I will take a look at the source code and include only the part I modify as needed. But it also depends, and this is a really important, it depends about the time we need to get it delivered or deadline. So this is something that I wanted to elucidate here. I am allowed to be that annoying guy who writes my own implementation of the observer pattern because I have the time to do that. I picked a bad example because writing your own observer pattern, actually, you can do it in like 10 minutes if you know what you're doing. But this is a really key point. The more, by saying that I'm going to take the time to learn it under the hood, I'm assuming I must be in a position where I don't have super strict deadlines. Or maybe I'm in like an elite programming team and there's just a rule that you don't write anything you don't use any third-party libraries. But let's say I wind up in a situation where I'm in a company, they want me to solve a problem really quickly and I don't have time to solve that whole problem myself. Just use Retrofit. And I totally agree with that point. Great point by Chaitin as well. So this is really what I'm trying to get at here. And for the beginners watching this, I'm trying to give different opinions and perspectives and what are the actual project requirements that would lead you to prefer a certain option, because it's not an easy answer. And I thank you guys so much. This is wonderful to have this debate going on. Let's go to Gabor. Libraries in theory are there specifically to hide the magic in a predictable and reliable way so that it solves your problem without too many costs being forced upon you. Completely agree. That is, let's use, instead of writing your own solution, you want something that you can just plug in and it works. I used a visual analogy there. Yep. Harish mentions Retrofit does look like magic for beginners, and now Room, and that's another great point. We're getting lots of great points here. I keep saying that, but that's here's an interesting dichotomy. The more the framework hides from you, the less you know about what it does. And this is simultaneously, this is both a feature and a flaw. And I want to point something out here. I've been saying this a lot in this episode. I've been saying that progressive web apps are a feature and a flaw. Native is a feature and a flaw. And then earlier on, I was talking about software architecture. Where is it? I talked about the same thing, feature and a flaw. So we see this, the Apache S, where did that plug come from? It came from my computer. I'm running off of my uninterruptible power source. God, I can't talk today. I apologize that I'm that tired. This is a common theme. And it's so important when you're comparing things. And so many people do this on YouTube. They're like, Python is the best language. Node.js is the best framework. And it's like, that's just a dumb statement. It depends on what the project requirements and personal preferences are. All right. So Gabor continues to say, however, before... yeah. Before I pull in a library, I check the source code first to see if it does exactly what I want and if it seems reliable in the first place. And that's an important one. And this is tricky because beginners, at least I can speak from personal experience here, it was really, I felt intimidated by libraries. So by using libraries all the time, I was scared of like looking underneath. And I realized that it's such a valuable skill to be able to do these things yourself. And this was, earlier people asked about Dagger 2 and Hilt. And what I advised the person asking is, the first thing you should do is understand what these libraries are doing for you. Understand that Dagger 2 is generating this for you. And in a small application, this is very not complicated. So no matter how complicated Dagger 2 itself is, under the hood, it's actually doing something really simple in a sense. It's just that you can configure it for a giant application, which makes it more complicated. So, anything else? We got tracks here. Also depends on what exactly the library contains. If you need only a small part of a library, it's easier to copy-paste the part from the source code and not import the entire lib. That's a useful point that I didn't think about. So if it's an open source project, you're allowed to do that. And that's something I never really... I've never done that myself. Like I've looked at how libraries do things and written my own code, but I realized that that might actually be a really good middle-of-the-road solution. If I understand the code and it's open source and it solves the problem, but I don't need everything else that comes along with it, then that's a good point. Also, Gabor mentioned, when I had to work on an SDK library, I used HTTP URL connection, so I would not have any dependency on any third-party framework. There we go. Project requirement. Not depending on any third-party framework to solve a particular problem. All right, folks. What are we at here? 2 hours and 8 minutes. I think I'm going to call it a day at this point. And thank you for the interesting discussion. If I remember, I would like to actually cut this part of the video and obviously give shout outs to everyone who participated in this little debate. And I appreciate the contributions here, because we just covered pretty much everything you would want to know about making the decision of whether you should write it yourself or use a library, a third-party library specifically. And I feel like that was a good little discussion. And yeah, I learned a little bit too. All right. Yeah, that's right, Chayton. Chayton brings up that, I'll just tell this story and then we'll call it a day. About 2 or 3 years ago, I applied to an Android developer position, and I was quite comfortable with Android development, and they did something which really threw me for a loop. Number one, they asked me to write in Java, and I had been writing Kotlin for 2 years at that point, so I was way more used to Kotlin syntax. And then the other thing they did is they said, in order to complete this programming challenge, you may not use any third-party libraries. And the challenge was, if I can remember, so coding challenge. Did I spell challenge correctly? Man, I just can't type today. Very dyslexic. Coding challenge. Coding challenge asks. Sorry, I'm tired. Coding challenge. So Java only. No third-party libraries. And then the write a request. What was it? I can't remember exactly. So write a HTTP call to write a call to a REST endpoint and parse and display the result in the UI, and it was a JSON response. And then 2, write a speed test. And yeah, you're right, the Apache. So this was the challenge. Now, I could have done this fairly well. I don't know if I would have finished number 2, but they did this. And the other thing they did is they gave me 2 hours to do this, which is pretty brutal for a coding challenge. Certainly not something I would ever do. So anyways, but you know, they're their company, it's their rules, whatever. So I made a couple of huge mistakes during this challenge. So the first mistake I made is I didn't actually have a clear definition of what a third-party library is. And in fairness, I mean, I think this definition differs between people. So the main thing is the definition I use now. Let me write this down below. The definition I use now for a third-party library is like this. Not part of the standard library. So again, this could be kstd lib, jstd lib. You get both if you write Kotlin, which is cool. Not part of the platform. So for example, just pure Android SDK in the case of Android. So this is really the two things. This is how I would call that. Now, at the time, I thought that because Volley was written by the Android team, if I'm not mistaken, yeah, it is, that it wasn't third party. And that was wrong. That was wrong. They ended up wanting me to use or something like HTTP URL connection, which is Java standard library. JSTD lib. So anyways, suffice it to say, I completely failed this challenge. I bombed it so hard. I'd never used anything other than Retrofit to make a REST call. I had my library and it made me feel like a programmer. It made me feel so safe until I realized that I had no idea what it actually did. Also, it returned, this thing returned, it was a JSON response. And I don't know when the last time any of you has looked at the Java APIs for JSON, but despite the fact that they're probably like 20 or 30 years old or something, they still are confusing and they suck. So I couldn't use JSON to like deal with it or set up a, what do you call that, a Moshi adapter for Retrofit. So basically, this all of this resulted in me epically failing this coding challenge. I did so poorly, and they told me like, we're surprised at how bad you are at Android, and I'm like, what? And it's just really that it was a perfect storm of things that I sucked at. So, anyways, just an interesting point. Gabor mentions, this makes me wonder if people consider Jetpack fragments and recycler view to be third party. You know, by this definition, anything that gets imported in Gradle, anything here is third party. But I don't know. You know, it just, that's why, whole Jetpack is third party by that definition. I'm not saying people should use that definition, but that was the definition they used, and over time, the reason why I've started to adopt this definition is just because it's very easy to understand. It gives you a clear answer what is third party and what isn't. But that's the ironic thing. The Android team, the Android SDK itself alone was developed by the Android team. Volley, or Jetpack fragments, not to be confused with just like the SDK fragments, is created by the Android team. So why is it third party? And really the only definition where that makes sense is just this one here. All right. Chayton mentions, I still don't know how to parse JSON to data class without JSON or Moshi. Yeah, I had like all of, I don't know, 5 minutes to learn how to do that in this challenge. I did manage to set up Volley, but ironically, they didn't want me to use Volley. But it was the first time I'd used Volley because I used Retrofit. And then I made it as far as like being able to get the JSON response. But at that point, I'm like, I don't know how to deal with this JSON response in pure Java. So, anyways. All right, people. Any final questions or comments before I go? Oh man, I feel really tired right now. I'm kept alive entirely by this caffeine. Yeah, pretty fun episode, although I think I'll be in better mental capacity next episode. So, we'll see. All right, well, that's going to be it for today. Thank you so much for showing up and participating and staying up late, some of you. I do appreciate it. And hopefully today was a good episode. And for my content, I'm going to be working on more of my Kotlin Compose Android tutorials. The second part of that tutorial was released recently. So if you want to learn how to use some basic and advanced Kotlin features in a project, not just random code snippets, which is not the best way to learn and teach in my opinion, then check out my channel because I'll be cranking out some great Kotlin content. Thank you so much for watching, everybody. And peace out. Happy coding. We'll see you next Sunday, hopefully.